So part of the third rule is in many instances, you will have multiples of those substituents, of the same substituents. So like in this case, we have two chloro substituents, two chlorine atoms. So then we use, if you remember from Gen Chem, di, tri, tetra, di means two, tetra, tri means three, and tetra means four, etc. for more than one identical substituent. Do not forget to use the number to indicate the location of the identical spaces. I'm going to clearly indicate what I mean by that. However, you need to remember that whenever you have di, tri, tetra, sec, tert, any of these, those are ignored in alphabetizing substituents. So you do not take into account di because it has a D, or tri, or tetra, or S, or tert. Those you just ignore and you look at the substituent name. However, iso and cyclo are not, so these have to be alphabetized. You have to use your alphabetical order. Well, this is all going to clarify what we mean. So let's begin. What's the longest chain? You see it. Right there. Now, you are to count to give the numbers the lowest possible they can get. Well, let's see. What is this? This is a chloro. You have two of them. The number is two of them, two substituents. They start with a C. And what do you think this group is right here? So it's two carbons. So that's from ethane, which is ethyl. Of course, the C wins. So you have to number from this direction. So you have 1, 2, 3, 4, 5, 6, 7, and 8. And then we ask ourselves, what do we have? Well, I have two chlorine atoms, so that's two substituents of chlorine. And I have an ethyl, as I said here. Now, when I say about the di-tri, and also here, do not forget to use the number to indicate the location of identical species. This is what I mean. When you start naming this, you say two, you might be inclined to say, okay, 2-dichloro. No, you have to include the 2 twice. So that's 2,2-dichloro. 2,2-dichloro. The ethyl is at the 5th carbon here. So that's 5-ethyl. And what is 8? Octane. So again, if you go back, 8 from octa-octane. That's the correct name. If you do 2-dichloro, that's not correct. That is wrong. Now, in this case, it did not probably matter because the D comes before the E. But even if you had a di, let's say, fluoro here, it would not be alphabetized. It would actually have to come after the ethyl. So do not take into account the di or any of these listed here. Let's go to the next one. The next one is very important and it's often missed by students. This one says that when both directions lead to the same lowest number for one of the substituents, the direction is chosen that gives the lowest possible number to one of the remaining substituents. In other words, first point of difference, number the chain so that the locant or the location at the first point of difference has the lowest value. Okay, so you might be inclined to say, well, if I have this number right here, if I have this one, it doesn't matter. I have the same substituent. This is methyl, and these are both methyls. So you say, well, why does it matter which way I start numbering? It does. If you highlight your longest chain, this tells you that I always like to say when I was in class is, you kind of like grab your pencil and you keep moving. Once you see more than one substituent on that first carbon that they meet, like here, notice how I'm approaching. They meet here and they meet there. If you see 2 on one of them, then that's where you should start numbering. For alkanes. So in this case, the correct numbering should not be, from here, it should be from here. 1, 2, 3, 4, 5, 6, and 7. And I'll show you why. This numbering would give us obviously 2 methyls and another one here. So you would name it 3, watch, comma, 3, because I have 2 at the 3. But wait, you have to indicate this one too. 5. What is 3 substituents? Trimethyl. And of course, 7 is heptane. If you number them the other way around, if you go 1, 2, 3, 4, 5, 6, and 7, and you go, okay, I have 3. That's the first one. And then look, 5, 5, trimethyl heptane. Well, this would be unacceptable. These numbers are bigger. Oftentimes you might be, developing a rule here or a pattern that, a generalization that maybe it's the lowest sum. It's still not the sum. Here, yes, the sum applies, but you want, again, the substituents to have the lowest number possible. So this would be correct and not the last one, not the second one. So the numbering should be from this side, not from the other side. If the lowest number, if the same substituent numbers are obtained in both directions, the first group alphabetical receives the lowest number. Very well. So we start the numbering here. If you count, so here's our longest chain. If you count from this way or that way, you will get the same substituent numbers. Let's see them. If I count this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I have 7 and I have 4. So let me erase that. And even if I count the other way around, I count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I have 7 and I have 4. So you're obtaining the same substituent numbers. Where do you number from? Well, as we said before, the first alphabetical order received the lowest number. So it seems like I'm repeating what I said before here, right here. But it's because really, you will see here, especially with the alkyl substituents, you have to watch out for those. So I put an example here where it's with the bromine, kind of easy to tell, but with the substituents, with the alkyl substituents, carbon made right here, hydrocarbons, you really have to watch out for them. So therefore, we are going to erase the red right here. Why? Which one do we choose? That's the question. Well, let's pay attention. This is called methyl. While this right there, like a fork, if you go and look for it, this would be an isopropyl. Now again, why did I put this here again? Because I said to you back here that you should not ignore iso. Iso is used in alphabetizing. So in this case, this is an I, and that's an M. So therefore, isopropyl should have the lower number. Isopropyl should have the lower number. Here we go. Let's delete then the numbering on the bottom right here. So the name here would be 4-isopropyl. Seven methyl. And if you don't know what 10 is yet, it's okay, is decane. Decane, D-E-C-A-N-E, from deca, decane.